In session 6, in the lesson of Structure of the Atom, we're going to investigate the following objectives. Define atomic mass and the molar mass. Define mole and Avogadro's number. Calculate the number of mole using the formula N equal m over m. Recognize the chemical symbols without Z and A for the first 20 elements of the periodic table. To begin with, watch this video to infer the notion of the atomic mass.
Can you tell me what atomic mass could be? Yes, it simply means the mass of an atom. But how does it get determined? Imagine we have a bag which is made up of extremely thin material. So thin that it almost does not have any mass of its own. Now we fill this bag with some stuff inside. If this bag is placed on a weighing scale, then can we say that the total mass of the bag will be the sum of the mass of all the objects inside it? Absolutely. Similarly, the mass of an atom can be calculated with the help of the subatomic particles in it. But we know that among all the subatomic particles, electrons have negligible mass. That is, they are considered to be almost weightless. So what are we left with? Yes, we have both protons and neutrons in the nucleus. And these two do have some amount of mass is what we know. Now tell me one thing, which among these two particles should be considered? Shall we consider only the mass of protons or only the neutrons? Or both together? Well, since both have a significant amount of mass, we will consider the mass of both together. In a single atom of aluminium, we have 13 protons and 14 neutrons. Summing up the two, we get 27 units, which is the atomic mass of aluminium. Now let's take another random example of chlorine. A chlorine atom has 17 protons and 18 neutrons. That means the atomic mass of chlorine will be 35 units.
After watching this video, we infer that the atomic mass, it is the mass of an atom. It is calculated depending on the number of protons and the neutrons. That means the mass number A. Its unit is U or AMU, which means atomic mass unit. So simply, the atomic mass is equal to AU. We substitute the value of A and the unit is U or AMU. Now watch the video about mole and Avogadro's number.
When we go to a supermarket, we always buy things using standard values. In other words, we always take 1 kilogram of rice or 200 milliliters of fruit juice. Fruits are sometimes counted using the unit dozen. 1 dozen means 12 of something. These are terms used in everyday life. But what if I want to measure something in terms of the number of tiny particles present in it? Let me explain this in detail. Looking at this pure gold, can you tell me how many gold atoms are present in this? Or wait, looking at this glass of water, can you tell me how many water molecules are present in it? You will probably say that it's practically impossible to calculate the number of atoms or molecules in these examples. But astonishingly, chemistry has an answer to this as well. That brings us to the concept of mole. What does it mean? It's very easy. 1 mole of anything has 6.022 times 10 raised to 23 atoms or molecules or particles present inside it. Isn't this number huge? If I have to write down the zeros, this is how big the number will look. 1 mole of anything has these many particles. If I give you 1 mole of pure gold, then what will the number of atoms in it be equal to? Yes, these many atoms. And 1 mole of pure water will have these many molecules. But what is the scientific definition of a mole? Scientifically, 1 mole is defined as the amount of substance that contains the same number of atoms, molecules or particles as there are atoms in 12 grams of carbon, 12. Yes, even I didn't understand it when we read it for the first time. Let me break it down for you. Let me remove this definition from the screen. What we have on the screen now is 12 grams of carbon-12. Carbon-12 is one of the isotopes of carbon. Now 12 grams of carbon-12 is what was taken as a standard. What's so special about this? Can you guess the number of atoms here? Yes, it's 6.022 times 10 raised to 23 atoms. Now that you've understood this, let me repeat the definition for you. 1 mole is defined as the amount of substance that contains the same number of atoms, molecules or particles as there are atoms in 12 grams of carbon-12. Did you understand the definition now? It consists of two simple parts actually. It tells us that this part is equal to this part. The number of particles in 1 mole of a substance is equal to the number of atoms in 12 grams of carbon-12. That's it. That's all the definition tells us. Many people get confused when it comes to the concept of mole. Let's take many more examples to be absolutely sure. How about taking the same example of pure gold and pure water? When we say 1 mole of pure gold, then according to our definition, it will have the same number of atoms as the number of atoms in 12 grams of carbon-12. That means 1 mole of gold will have 6.022 times 10 raised to 23 atoms of gold. Similarly, water will also have the same number of molecules as the number of atoms in 12 grams of carbon-12. That means it will have 6.022 times 10 raised to 23 molecules of water. Remember, the definition uses carbon-12 as a standard. It is used to compare the number of atoms or molecules or particles present in the substance. But what's the mystery behind this number? A scientist named Lorenzo Avogadro. So the number 6.022 times 10 raised to 23 is called as the Avogadro's number. It is just a number used to represent quantities. It's similar to how we use the word pair for 2 or the word dozen to represent 12. Similarly, Avogadro's number is the term used to represent 6.022 times 10 raised to 23 number of any entity. So can we go to a shop and say, I want Avogadro's number of chocolates? Of course we can. The only problem is that the shop won't really have those many chocolates and neither will we be able to carry them back home. So getting back to the concept, Avogadro's number is just another number used to represent quantities. But the number is so huge that using this in daily life is not practically possible and advisable. Then why does the number exist if we do not use it? Yes, the number is not commonly used in daily life by us. However, it comes to the rescue of chemists that work with atoms, molecules, electrons, and many such small entities. That is the reason why it's used to calculate 1 mole of any substance.
The notion of the number of moles that is shown in the video, it is equal to Avogadro's number that is represented by Na, which stands for 6.022 times 10 power 23. Surely this number is not for study. It is equivalent for the number of particles found in 12 grams of carbon-12. So 1 mole is equal to 1 Na. Now the last video about the molar mass.
We know that 1 mole of carbon-12 is 12 grams of carbon-12. That's because 12 grams of carbon-12 has the Avogadro's number of atoms. Now let me ask you a question. If you answer this correctly, it means you've understood the concept of mole. What will be the mass of 1 mole of pure gold? Will it be 12 grams? The answer is no. It will not be 12 grams. Note that in both cases, the number of atoms is the same, but the mass of an atom of gold is different from the mass of an atom of carbon-12. Hence, the mass of 1 mole of gold will definitely be different from the mass of 1 mole of carbon-12. So 1 mole of gold weighs around 196.97 grams. That is because mass of gold atom is different from the mass of carbon-12 atoms. Similarly, if we take 1 mole of gold, 1 mole of silver and 1 mole of copper, then all of them will have the same number of atoms in them. That is 6.022 times 10 raised to 23 atoms. This number is the Avogadro's number. However, the mass of each one will be different. That's because the mass of individual atoms that make up these elements is different.
The molar mass. If we take 1 mole of matter A and 1 mole of matter B, which are completely different, and we weigh them, we find out that the mass of A is not equal to the mass of 1 mole of B. So the molar mass, which is the mass of 1 mole of a substance, it differs according to the nature of the substance. It is measured in gram per mole and represented by capital M. Simply, the rule is capital M, which is the molar mass, it's equal to A gram per mole. We substitute the value of A for the atom and the unit it is gram per mole. As an application, if we have this atom fluorine having Z equal 9 and A equal 19, what is the molar mass of this atom? So, after writing the rule, we substitute the value of A, which is 19. That means the molar mass of this atom is 19 gram per mole. The answer without the unit is meaningless. Calculation of the number of moles N. In order to calculate the number of moles N, we have the rule represented in the following triangle. The number of moles N, it's equal to the mass M over the molar mass capital M. As an application, to calculate the number of moles found in 2.7 gram of aluminum piece, given that the molar mass of aluminum is 27 gram per mole. We write the rule N equal M over molar mass. We substitute the mass, which is given 2.7 gram, and the molar mass, which is also given 27, so to get the answer 0.1 and the unit mole. Keep in mind the following terms having the same value but with different units: the mass number, the atomic mass, and the molar mass. All of these terms, they have the value which is equal to A, which is Z plus M. However, they differ in the symbol and the unit. The mass number having the symbol capital A is without a unit. However, the atomic mass, it does not have any symbol, its unit is U or AMU. The molar mass having the symbol capital M, its unit is gram per mole. And finally, you are responsible for the chemical symbols for the first 20 elements, which are hydrogen H until reaching calcium, whose symbol is Ca. As an assignment, you have to solve the extra sheet for